The next conic section on our list to explore is called the hyperbola. Let's take a look at this in Desmos. And I wish I had thought to do this for the ellipse, but if you wanted to make an ellipse, all you would have to do is change that minus sign to a plus sign. What you see over here on my first line in Desmos is the standard form for the equation of a hyperbola that is opening to the left and to the right. As you will see, we have these offsetting curves. This hyperbola is opening to the left and to the right. If I instead make the x term negative and the y term positive, then I have a hyperbola that opens up and down. Now ordinarily we would put the y term first, but just for ease of typing, I have it written this way. We'll explore this in much more detail, but I just wanted you to see what these look like. So I'm going to put it back as it was, and we're going to explore this hyperbola just a little bit. Of course, remember when you are exploring in Desmos yourself, you can change the colors and make them anything you want to. I love reverse contrast, but I just don't think it shows up as well in the video, so that's why I've got it like this. All right, so I have, when you type in your equation, Desmos is set to identify x and y as variables. But when it gets the h and the a and the k and the b, it asks you, do you want to add sliders? And that's exactly what you want to do. You want to add sliders. Well, when h changes, we are familiar with what happens with h and k in conic sections. We've seen it with the circle, we've seen it with the ellipse, and now we're seeing it with the hyperbola. The hyperbola has a center. It's not actually on the curve itself, just like the center isn't on the circle, the center isn't on the ellipse, but it has a lot to do with the drawing of the curve. So h affects the center, k affects the center. Okay, so no surprise there. But let's talk about what happens with a and b. So as a changes, notice the curve is changing in two ways. The vertices, which are these points here, where the curves make their turns, are changing. The location of those is changing. Also, the curvature is changing. This is a very wide curve. This is a more narrow curve. So A affects a couple of different things. And I'll put that back to 1. And let's consider what happens with B. So as I slide B along, we see it's not changing the location of the vertices, but it is having an impact on the curvature. All right, so we're exploring, and I encourage you to explore in great detail how to do these and let Desmos help you with your understanding. The curves are guided by lines called asymptotes. We're familiar with asymptotes from our study of rational functions in previous courses, exponential functions, logarithmic functions, and then certainly in trigonometry we have seen our fair share of asymptotes. In this particular case, the equation of the asymptote, one of them is y equals x, shown here. One of them is y equals negative x. And you'll notice the curve is getting closer and closer and closer to these asymptotes. Although it looks like it touches it, it does not. If we zoomed in a little closer, we would see that, well, you know what, it's not actually intersecting, it's just getting closer and closer. Now eventually Desmos might have them cross because it can't help it, it's just doing the best it can, but it really does not. The graph is approaching those intercepts but not intersecting those. Alright, so let's take a look at a couple of equations of hyperbolas in conjunction with their graphs and see if we can draw a few more conclusions. As mentioned when we were looking at Desmos, the x being first tells me that this hyperbola is going to open left and right. So I shouldn't say x being first, I should say x being the positive term. In the hyperbola, one of the terms will be positive, one of the terms will be negative. So this tells me it's going to, the curves are opening left and right. This 9, and then there's this understood 1 down here. Both of these give me important information when it comes to drawing the graph. This actually gives me 2 pieces of information. This gives me 1. So if you remember from the ellipse, the square root of the denominator was helpful there. Same here. So we're going to go ahead and consider the square roots of each of these. This 3 is telling me 2 different things. It's telling me the distance from the center to the vertices. Notice, here's my center at 0, 0. I have a vertex 3 to the right, and I have a vertex 3 to the left. It's also helping me identify the slope of my asymptotes. So I have the asymptotes here in pink. I've already labeled that the slope is 1/3, up 1, right 3. On the other side, up 1, left 3. So we have positive or negative 1/3. Well, notice the slope of the asymptote being positive or negative 1/3 comes from that 1 and that 3. So when you're trying to find the slope of the asymptote, it's the square root of y's denominator over the square root of x's denominator. Let that sink in because it's super awesome. Slope is always change in y over change in x. So that's a good way to help us remember that. So let's take this knowledge and look at another example. Here we see the y term is the positive one, so that tells me this opens up and down. Its denominator tells me how many to move to get to my vertices from the center. Square root of 4 is 2. So I go up 2 and I go down 2 to find those. Okay. Last time it was x, the denominator of x, because x was the positive term. This time y is the positive term, so it's the denominator of y. And then the last piece of information that we can get for now is the slope of the asymptotes. I've already got them marked and labeled that the slope is 2/5 and negative 2/5. That makes perfect sense because the square root of the 1 under y over the square root of the 1 under x would be positive or negative 2/5.